Hello, everyone. Welcome back. Today, we're going to talk about dividing rational expressions. In these three examples, we are going to simplify the following rational expressions and also state any restrictions. Okay, so in order to do this, my very first step is going to be to factor as much as possible. So let's do that. Okay, so the only thing that can be factored in this first one is the denominator of this first fraction here, of this first rational expression. Notice that it's a difference of squares, and so we can use the difference of squares formula in order to factor it. Recall that the difference of squares formula states that a squared minus b squared is equal to a minus b times a plus b. So in this case, we have 3x over x minus 3 times x plus 3 divided by 2x over x minus 3. So that is step one. Step two is we're going to divide this as we would any fraction, which means that we're going to take the reciprocal of this second rational expression here and then change the division sign to a multiplication sign. Okay, so that means that our next step is going to be 3x over x minus 3, x plus 3. And then instead of divided by, it's going to be times x minus 3 over 2x. Okay, and then now what about our next line here? Well, I'm going to cancel out anything that can be canceled out. So x minus 3 and x minus 3, those can cancel out. This x here can cancel with this x here. So we end up getting 3 over 2x plus 3. And that's as simple as we can get. And so this is our final answer. Now, what about stating restrictions? So in the case of rational expressions, if any value of x would cause 0 to be in any denominator at any time, that means that it would be a restriction because we can never, ever, ever have 0 in our denominator and still have a valid expression. So I'm going to look back at this step over here in order to determine this. The denominators here are x minus 3, x plus 3, and x minus 3. So that means that x cannot equal 3 and x cannot equal negative 3. And then I'm also going to look at the step after where we flip the fraction. Here where we flip the fraction, notice that we have 2x in the denominator of our second fraction. So that means x cannot equal to 0 either, because that would cause, in this step here, in this highlighted step, for us to have a 0 in the denominator of our second fraction. We can't have that. So there we go. Here is the final answer. And here are the restrictions. Okay, let's try the second example. So same thing here. My very first step is I am going to factor wherever possible. So in this case, there's also only one thing I can actually factor, which is going to be the denominator of our first fraction. And so I'm going to use the difference of squares formula once again to factor this. In the same step, I'm actually also going to change my division sign to a multiplication sign, and then I'm going to take the reciprocal of the second fraction here. Okay, now for our next step, let's see what we can cancel out. We can cancel out, here we have 5x squared in this numerator here. I can cancel out one of these x's, so the squared here with this x over here, because recall that x squared is just x times x, and so one of those x's can cancel out with the x in the denominator of the second fraction. Then we have x minus 5 and x minus 5 can cancel each other out, and so we are just left with 5x over x plus 5, and that's as best as we can do. Now, what about the restrictions? I'm going to start by looking at the first step, or actually just the question here. In this first step, I notice that x cannot equal to 5, right? Because that would make this denominator here a 0, and that doesn't work for us. And then I'm also going to look at the next step, right? The key is you want to look at the step before you take the reciprocal and the step once you've taken the reciprocal to ensure that you have gotten all the possible denominators that you need to. So in this second step here, I noticed that we have x minus 5 times x plus 5, meaning that 5 and negative 5 are restrictions. So we already have 5, but we don't have negative 5, so I will add that on our list. And then notice right here that we have an x. Now I know I'm aware that it gets canceled out, but it doesn't matter. At one point, x was a denominator, and so therefore x itself cannot equal 0, otherwise the denominator is 0. And there we go. So overall, this is our final answer right here, and these are our restrictions. Okay, let's do one more example for this one. First things first, I need to factor wherever I can. I can factor the x squared minus 9 because it's a difference of squares. It's going to be equal to x minus 3 times x plus 3. And then the denominator here, x squared minus 6 or minus x minus 6. Let's see if that's factorable. I believe it is. Can we find two numbers that multiply to negative 6 and add up to negative 1? Well, yes, negative 3 and negative 2. They're numbers that multiply to 6 but add up to negative 1. So therefore, we have x minus 3 times x plus 2. And if you're ever unsure when you're factoring whether or not you factored correctly, you can always expand and simplify to ensure that you have. And then we have that this is divided by x minus 3 over x plus 2, like that. Then I'm going to keep switch flip, so I'm going to keep this first fraction the exact same, so I will just copy it. Then I'm going to switch the division sign to a multiplication sign, and then I'm going to flip this fraction, x plus 2 over x minus 3. And now I'm going to cancel some stuff out. I'm going to cancel these x minus 3's with each other. I'm also going to cancel these x plus 2's. And so all I have left is x plus 3 over x minus 3. And there's our final answer. As for restrictions, again, we want to look at the step before we take the reciprocal and the step once we've done so to ensure that we've got all possible restrictions. So let's start by looking at this step. So the denominator terms here are x minus 3, x plus 2, and x plus 2 again. So therefore, x cannot be equal to 3 or negative 2. And then if we look at the step after, I notice that we have, x minus 3 and x plus 2, and then we have x minus 3 again. So actually in this case, we already have all of them covered, but we won't always. So it is important to check both steps, even though in this case, we actually had all of them from the start. And there we go. All right, any questions, feel free to leave them in the comments section, and we'll see you for the next one.